All right, let's look at one last TI Nspire tutorial dealing with derivatives. And in this one, I'm going to show you how to actually find the derivative, the general derivative of a function, which is a CAS-only feature. You can't do this if you don't have the CAS version of the TI Nspire. We'll find the horizontal tangent or the x-coordinates of a horizontal tangent and then calculate the numerical derivative at a point. And if you want to print the sheet that I'm using for these problems, you can go to this bit.ly link right here. And let's go on and look at the problem. So we have this function, and it's a pretty layered question, a lot going on here. We have f of x equals that stuff. Find the value of f double prime of c. So we want the value of the second derivative, which is a little bit unique. Usually you're only asked for the first derivative. But then we're asking for the value of the second derivative where your function has a horizontal tangent. So a few things to unpack here. I'm going to start with the end. The x-coordinate at which f has a horizontal tangent. That means we need to find the derivative and we need to set the derivative equal to 0. Now on the actual AP exam, they will write a question where this isn't really something you could do because they want to make sure that students with CAS-capable calculators do not have an advantage over students without CAS-capable calculators. So you wouldn't really see this on the AP exam. However, it is a feature that I think is good to know if you have that CAS. So I need to find the derivative and then I will graph the derivative. I will find the x-intercepts of that derivative. That will tell me where my derivative is 0, which also tells me where my tangents are horizontal. You should be able to quite easily find the derivative by hand. However, we're going to find the derivative in the calculator for practice, and there are a few questions here about this function f of x. So I'm going to start by defining f of x in my calculator, and I'm going to show you a couple of mistakes that students often make on functions like this. So I'm going to go New Calculator, and I want to define f of x, colon equals, and I've already forgotten what it was. It was x squared minus x cosine x. And here's what a lot of students will do. X squared minus x trig cosine x. And as a human, you look at that and you understand what it is. The calculator says, hey, it's done. That is now stored. Now I want to find the derivative of that function, and we're going to run into a problem. The way you do general derivatives is you hit Menu, Calculus. I want the derivative, not the derivative at a point. I want the general derivative, and the CAS-capable calculators will give you a derivative in terms of x. So you need to do the derivative with respect to x, and I want to differentiate what I just defined as f of x. And now what's going to happen when I hit enter is something interesting. It will correctly differentiate the x squared, but it did not differentiate x cosine x. And the reason it did not differentiate that, it's not because the calculator doesn't know the product rule, it does. But the calculator doesn't recognize this function because in these calculators, and this is true for programming in general, if you ever type a string of letters that are not separated, the calculator or the computer will read that string of letters as one command. So my calculator right now is very confused. It does not know what the function x cos is. The calculator doesn't see x times cosine, it sees x cos. So we actually need to fix that so that it is actually x times cosine. So I'm going to go up and I'm going to delete this line. I don't need that anymore. I think I'm going to delete it. There it goes. All right. And if you want to edit something, you don't have to retype the whole thing. You can actually go up and highlight it with the arrow up button. Make sure the whole thing is highlighted. If you press enter, it will copy it down to the editable screen. And so we need to fix that so it's x times cosine. And so a lot of students will say, okay, I'll just put parentheses around the cosine. Now, notice it swapped the cosine from italics to regular print. That means the calculator recognizes the cosine command now. It looks like x times cosine x. It says done. And once again, when I try to find the derivative, I'll go menu, derivative, with respect to x of f of x. It now tells me that the name is not a function. And again, we need to learn how to talk to our calculators. The calculator is not seeing x times cosine x. The calculator is seeing that x the same way you see the f right here before the x. That's f of x. The calculator thinks this is x of cosine x, and it's trying to plug the function cosine x into some other function x that has not yet been defined. So you never do x with an open parentheses after it because the calculator will see it as x of things. So once again, I need to go up. I'm going to delete this. I'm going to delete that. I'm going to copy that down. And we simply need to put a multiplication dot between the two. Now the calculator will recognize the function as x times the cosine of x. I can now go to calculus, derivative. I can ask the calculator to find the derivative of this function, and we finally get something that looks right. So we finally have our derivative. Now, back to the problem. Remember, we were finding the derivative because we're looking for horizontal tangents. I need to graph this derivative. I need to find where this derivative hits the x-axis, and then I need to use that answer to find the value of the second derivative at that x-coordinate. So I'm now going to graph that function. And keyboard shortcuts on a computer mostly work the same on these calculators. I'm going to highlight with arrow up that derivative. I'm going to hit Control-C to copy the derivative. I will add a graph page, Control Add Page, add a graph. I will paste that derivative, Control V, and there it is. Very nice. You don't have to write it down and retype it. There's my derivative. I am looking for where the derivative is equal to 0. I see only one such place, so I'm going to go Menu, Analyze. I want the 0 of this function, drag across, and we have 0.3889, and in my previous video I mentioned that on the AP exam you can either round that up to 0.389 or you can use what's called the truncated version of 0.388. And the thing is, I'm not done. I still need to use that, and I'm going to store this answer because I need to use that value in the second derivative. So I'm going to make a note. I'm going to let C equals 0.388, and I'm going to go to my calculator and I'm going to store that x-coordinate, and I talked about that in another video. If you click on it, it's highlighted. Go Control Store. It asks what variable do you want to assign to that. I will go with C, enter. That x-coordinate is now bold, and if you hover over it, it confirms that you did indeed link that as C. And I now need to, I'm going to go back to my work here, I now need to find the value of f double prime of C, and I can write C because I have in my work that C is equal to 0.388. If you don't write that, then you need to say f double prime of 0.388. So I'm going to write f double prime of C. Now I need to compute that in the calculator, and your calculator does have a derivative calculator, and you're expected to use it. So I'm going to go Menu, Calculus, derivative at a point. I'm going to use the variable x. I just stored the value for C, there it is. And this time I want to plug into the second derivative of the function I have already defined as f. I'm going to hit enter, and I have my answer right there, 3.118, and we are finally done with this problem.